Okay, substitution in the area between curves, Chapter 5, Section 6, Part 1. We start with Theorem 6, the substitution in definite integrals, which means we're back to having boundaries. And it says this: if g prime is continuous on the interval from a to b, and f is continuous on the range of g, then the integral from a to b of f of x f of g of x times g prime of x dx is equal to the integral from g of a to g of b of f of u du. In other words, we're going to change the boundaries with respect to u to make it easier. Otherwise, we could just substitute back in, but it's a real pain if we have to do that. So let's take a look at what this actually does look like. So we're going to take this example. So we're going to start with the integral from -1 to 1 of 3x squared square root x cubed plus 1 dx. All right. Knowing what we know, we need to make u equal to x cubed plus 1. Again, it's the inside part. That's the reason I chose it. Okay, I chose it to be, so that's the inside part. So du is 3x squared dx. So dx is du over 3x squared, which is kind of nice because that means that will cancel out. So, according to the rule, I'm going to integrate. I'm not going to put my boundaries down yet. I'm going to change this to u to the 1/2. I'm going to leave this 3x squared because I need them for a minute. I have du over 3x squared. I have one thing I haven't done yet. I have to adjust my boundaries based on u. So u of -1 is -1 cubed plus 1. -1 cubed is -1. -1 plus 1 is 0. So my lower boundary now is 0. I then also have to find u of +1, the top number. So 1 cubed plus 1 makes 2. So my top boundary has now turned into 2. All of that theorem says we can change the boundaries to make our math easier. And that's all it is. So in doing that, we find the antiderivative. So that would be u to the 3/2 over 3/2. Okay, I don't need c this time. Evaluated from 0 to 2. I do my math. Let's see, that 3/2 becomes 2/3 times 2 to the 3/2 minus 0 to the 3/2, remembering our fundamental theorem. 2 to the 3/2 is 2 square root of 2. 0 to the 3/2 is still 0. And we have 2/3 in front of it, so we end up with 4 square root of 2 over 3, final answer. The alternative to this is, now that I have my u right here, I would go back and I would say, okay, I'm going to take u, which is x cubed plus 1, to the 3/2 power and evaluate that from -1 to 1. Well, okay, pick one. It really doesn't make a whole lot of difference. This is not a difficult problem, so it turns out they're going to come out the same. However, this is just a little bit shorter and a little bit less confusing. Let's try that again. This one is for Ben, who loves trig functions. So here it is. We have the integral from pi over 4 to pi over 2 of the cotangent of theta cosecant squared theta d theta. All right, and again, I'm just going to tell you that u is the cotangent of theta. So du is negative cosecant squared theta d theta. Again, I'm going to divide, so du over negative cosecant squared theta equals d theta. I'll adjust my boundaries in a minute. Let's do this part first. So I have u cosecant squared theta times du over cosecant squared theta. Oops, that's a negative. I have to adjust my boundaries. So u of pi over 4, or the cotangent of pi over 4, cotangent of pi over 4 is 1. And I have to find u of pi over 2. The cotangent of pi over 2 is 0. I'm using my unit circle. We're fine. Okay, so far so good. So pi over 4 was at the bottom, so I'm going from 1 to 0. I know, we'll fix it in a minute. We have a negative sign right here, so we've got the negative of, that's the negative sign. But if I want to flip these over, that becomes positive again. So this is 0 to 1 of u du. Let me do that again. It's negative because of this negative. And then if I flip these, so I have the 0 on the bottom and the 1 on the top, I flip it so that also becomes a negative. So a negative and a negative makes it to positive. So I end up with u squared over 2 from 0 to 1. Well, let's see. 1 squared is 1 over 2 minus 0 over 2 is 1 over 2. Final answer. Not so complicated. Let's try a couple more just because it'll make it a little bit easier for everybody if we just keep practicing a bit. I don't want to make this video too long, but I do want to do a couple more just to make sure we're on the right track. All right. Okay, let's do this one. The integral from 0 to pi of 3 cosine squared x sine x dx. What should we use for u? Oops, there's an s missing. Okay, what should we use for u? Well, the derivative of sine is cosine. That's not a horrible idea, but it wouldn't be squared. The derivative of, you know what? Let's give it a shot and see. What do you think? Let's try. If u is the sine of x, then du is the cosine of x dx. Okay, that makes sense. Let's see. So dx is du over the cosine of x. I agree with that. I think I'm going in circles. Oh, you know what? This one's squared. Let's make u, let's cross that out. Let's try this again. Let's say u is the cosine of x. Then du is negative sine x dx. Oh, I like this better. If I divide, I have du over negative sine x equals dx. That sine x goes away. That makes me feel much better. Okay, so now I have an integral. I don't know what my boundaries are yet. I have 3u squared sine x times du over negative sine x. Ooh, I like that, because that goes away with that. And that negative sign can go with that 3, so I can do this. I'll fix the boundaries in a second. I can do that. Okay, so now I have to find u of 0, and I have to find u of pi. Or in other words, I need the cosine of 0, 0, not theta, and I need the cosine of pi. Well, let's think about that for just a second here. The cosine of 0 is 1. The cosine of pi is negative 1. My 0 is on the bottom, so I would have 1 to negative 1. If I want to flip those, that turns this into a 3. Integral from negative 1 to 1 of u squared du. I take the antiderivative, it's u cubed over 3 times this 3 in the front. Evaluated from negative 1 to positive 1. All right, I'm doing okay here. let's see. I have 1 cubed. I'm doing this right here. Okay, I have 1 cubed, which is 1, so I have 1/3. And then I have -1, so minus -1/3. And I have to multiply this by 3. So that's 1/3 plus 1/3 is 2/3 times 3 leaves me 2. What? Is that possible? Of course it is. Nice job. Yeah, you know, sometimes we pick the wrong thing and see it's not going anywhere, so we change directions. It's okay. That's what calculus is kind of about. We kind of have to figure out which direction we're going and move it around a little bit. All right, let's try another one. Let's try that one. The integral from 0 to 1 of 5r over 4 plus r squared dr. All right, think about that for just a second. Let me give you a chance to write things down. The most inside of things that I have is this, so I'm going to make that my u. So du is going to be 2r dr. So dr is du over 2. Okay, this 5 is just a constant, so it's okay. Oh, 2r, sorry. All right, so I'll fix my boundaries in a minute. If you want to think about this like this, it's 5r times u to the -2 du over 2r. That was a big step there. Let's make sure that makes sense to you. I replaced this with u. I brought it to the top, making it a negative exponent. I can cancel the r's, and the 5 and the 2 can come out in front. Notice I've not put the boundaries on there yet. I got to fix those. So u of 0, sorry, and I have to do u of 1. U of 0 is 4 plus 0, or 4, and u of 1 is 4 plus 1, or 5. So I'm going from 4 to 5. So I think I can do that. 4 to 5 of u to the -2 du. Take the antiderivative. Okay, take the antiderivative of u to the -2 is u to the -1 over -1. I'm going to evaluate that from 4 to 5, and I'm going to multiply that by 5 over 2. So I have 5 over 2, 5, top minus bottom, so 5 to the -1 is 1/5. That makes it -1/5. 4, that's 1/4. That makes it minus -1/4. So -1/5 plus 1/4, that would be 4 over 20 plus 5 over 20. My math is good here. That would be 1 over 20. 5 over 2 times 1 over 20 looks like 1 over 8. And that is the value we're looking for. Kind of complicated, not terribly. I'm going to leave there's some work to do on this. I'm going to leave you some problems to work through, but at least that gives you an idea of how I'm getting there. And we'll come back to those, and hopefully you'll bring your questions to class. See you then.